So the way this was found, and this is exactly how it was found in Alexander Lake, they were identical situations, is that in fall of 2012, Stormy Lake was being treated with rotenone for pike, which is an invasive species on the Kenai Peninsula. And they went out and did their motoring boat. It was actually a joint effort with the refuge and AF&G. And at the end of the boating around, there were not a lot of boats out there churning up the water. All these fisheries biologists are standing on the shore and they're looking down, and there's this green thing floating on the ground. Nobody knew what it was, and certainly it turned out to be Elodea. And that was September 2012. It was the first time it was detected on the Kenai. So we were really on top of this. We were out in February. We went out and started drilling through the ice on some of these lakes. And we actually surveyed and used a modified chimney sweep, and it worked out really well. The chimney sweep fits right through the auger, gets right in there. We actually just bent up the the little brass things, and it works really, really well. We were actually just able to sample through because we took this seriously right from day one. We wanted to get rid of this stuff because I've been around invasives for a long time down elsewhere, and know that this is a problem. And one of the things that was kind of, well, not cool, but it was impressive, is that when we first tested it out, we went to an area on Stormy Lake where we knew there was a lot of Elodea, and we punched it in the we weren't sure if the technique was going to work. We punched the auger through the hole, pulled it out, and as soon as we pulled it out, Elodea just spewed out on the ice. This is in February, okay, and it's kind of like what you're seeing over here in Eak Lake. This plant photosynthesizes year-round, and that's partly what makes it as invasive as it is that most of your native plants, in fact all of them, for all practical purposes, are senescing during the winter time. This plant is continuing to photosynthesize. It is green and it's floating under the ice. So we did exactly what we're doing here. And again, we're stepping this up pretty quickly. In that same February, we had our first stakeholder meeting in Nikiski, very similar to this, maybe a few more people, but we kind of went, had the same people came up, Lars and folks from CPRO, and we went through exactly this kind of process that we're going through here. And then we decided to do an integrated pest management plan. Okay, and the date on here is April 2014, and that's not quite right. That was, we actually went through multiple iterations as we developed this plan. We actually started it in the latter part of 2013. And then we had a number of people that jumped on board immediately. Well, the way we structured this is we considered ourselves a tech, and the reason I'm telling you this is I think this is a good template for you guys to consider as well. We kind of structured this as a technical subcommittee of the Kenai Peninsula Cooperative Lead Management Area. And that's a nice group to kind of associate with. We took a big lead here as the Fish and Wildlife Service, as the Forest Service probably would take a big lead here as well. We had folks like the Cook Inlet Aquaculture. We had the Kenai Peninsula Burrow. You'll see the burrow was a big deal for us. They ended up being our big funders. Kenai Watershed Forum, which is equivalent of the Copper River Kenai Project. So we had all the same kind of players. One of the other things that we did too is that we had private, because we're dealing with lakes with private landowners, we had private landowners that were actually on our technical subcommittee as well. And that was a real critical piece in the whole process. So you've already seen there's been quite a bit of sampling on the Kenai Peninsula, a total of 101 lakes. It was really critical for us. We realized right up front that this is a very expensive effort. And before we wanted to spend the money, we wanted to know, well, what's the distribution of Elodea on the Kenai. So in 2013 and again in 2014, there's a total of 101 lakes were sampled. In that process, we found it in a third lake, so it's Stormy, Back, and Daniels. They're all in that little square up there. They're all in this little square. And the lakes that we ended up sampling, you can't really see them that well here, that are in yellow. These were all high-risk lakes on the Kenai. By high-risk, I mean that there were a lot of landowners, a lot of floatplane traffic, in some cases a lot of commercial charter operations. A lot of them had public boat launches. We hit all the obvious lakes. And at the end of the day, we feel very, very confident that it is really restricted to this little piece up here. So 3 lakes, 2 watersheds, and right up next to the Cook Inlet. So with that in mind, we really started getting down to do some fairly intensive surveys. Here's Beck Lake. Beck Lake's 200 acres. You can see we have good bathymetry data. These are the dots, and you can kind of see the gradation. Red means that there's a lot of Elodea. not a lot. And we sampled it enough to feel confident that Elodea was fairly well distributed in that way. So there's two ways, and Andrew kind of alluded to this, there's two ways you can apply to do these kinds of herbicide treatments. You can do a whole lake or a partial lake. Partial lake obviously saves you money, but there's some issues with partial lake as well, because you're applying chemicals to part of the lake and hoping it stays there. Well, that's kind of tough. And when we looked at Beck Lake, we realized that that was definitely going to be a whole lake treatment. Stormy Lake, also a whole lake treatment. That was a 400-acre lake. There was one public boat launch there, and Alaska DNR, the state parks, they've been very good. They've kept it, that public boat launch closed for the 2 years of this effort. It's coming up the third summer now, and I think they'll keep it closed then too. So basically, they're giving us time to make this thing happen, to actually kill Elodea. Daniels Lake, very different. We feel like we caught this early. It was, turns out there was 5 areas, and we felt very confident. We sampled this multiple times, and we actually got out there very early in the spring, right after ice out, and there was great water clarity. We could actually see the Elodea in the ground. So we feel very, very good that we got this early on, and that's good because it was in the largest of our lakes. And so we ended up with these 5 treatment areas that represent really only about 50 acres, but because we have that dilution effect, we ended up treating about 100 of a 600 and something acre lake. And you'll see that this saves us a lot of money. What you see in red here, and this is what Andrew was mentioning, these sites, these fast test sites. Fast test is the analysis that you do. You send in these water samples. I send it to these guys, FedEx overnight. They process it in 24 to 48 hours, and we get back fluoride samples within 2 or 3 days. It's pretty cool how fast we can get back data. So this has all been touched on. These are all the reasons why we went with fluoridone. It's a systemic killer. By systemic, you contrast that with a contact killer, and I'll show you a contact killer in a minute. Contact killer is something that kills, you put it on the plant and it dies. The problem with that is that it's only killing what it touches, so it doesn't kill roots. So you can get an immediate response by killing the plant, but it's not really dead. It'll grow back if you have a perennial like you do with Elodea. So it's really important that you have a systemic plan if you want to actually kill it, because you need to actually be taken up by the plant and go through the root system. Andrew's mentioned, of course, that it kills by inhibiting photosynthesis. The big problem is it has to be in your water column for a long time. And in my case here, you'll see that it's actually probably for like 2.5 years in the water column. You can apply it as a liquid, or you can apply it as slow-release pellets, and we actually use both for different reasons. What's nice about it is it degrades primarily by photolysis, meaning by sunlight. Sunlight will destroy it after a given time. There's literally no restrictions on swimming, drinking, or fishing at the concentrations that we're applying. You can drink fish and swim in it the day you apply it, even while you're applying it. It's pretty remarkable. There are some. It's kind of weird if you use this water. If you're using it to pump it, say to water your lawn, which is what down here, it's not an issue. But if you do it, on the Kenai, you can actually you obviously have some non-target impacts on your grass. Instead of helping it turn it a little bit yellow, you won't kill it, but you'll not do it any favors. The other chemical we use is diquat, and diquat is a lot cheaper, but it's not a systemic killer, it's a contact killer. And the reason we use diquat, we use 1 round of it in Daniels Lake. And Daniels Lake was the lake that was the partial lake treatment. And what we didn't want to have happen is that partial lake treatment go from 100-acre treatment to a 660-acre treatment. So we used this diquat 1 time just because literally we get an immediate lethal response in 2 to 3 days. Bam, the stuff's dead, but it kills other things as well, so that's the danger of it. And so when we used it, we were doing a very selective application on these 5 small treatment areas in the lake. And then that was the last time we used it, and it really knocked it back. And I'll show you the data here shortly. So this is what it costs. Price tag down here, it's over $600,000. It's not cheap. What we ended up working out with CPRO is we have, over here, we've got 4 treatments over 3 years. We have two treatments up front, 2014. We've already applied that this year. I mean, we've already gone through all the paperwork and got it out there. And what we're doing is in 2014, again, Beck Lake, Stormy, and Daniels, we have Beck and Stormy are whole lake treatment, so we're treating the entire lake. Daniels is that partial lake treatment. So in Stormy in the spring, as soon as ice went out, we're talking June 3rd, June 3 or June 4th, we applied both a liquid form of fluoridone and a pellet form of fluoridone. The reason we applied both was the liquid, we wanted to get rapid uptake into the plant because it's starting to grow, it's springtime, it's starting to take off. So we put the liquid down, and then we put the pellet down because the pellet is a slow release, and it's starting to, and it releases over time in the summer. Daniels, because of the partial lake, we did both the dicot, and then we did the pelleted form. And again, we're not using the liquid form in the partial lake treatment because it will dilute immediately. So we're using the pellet, and then we put the dicot, which is a contact pellet. And then from there on in, we're using pellets all the way through. We're done with the liquid. The liquid was just that first application in June, and we don't use it again. And from here on in, we're using the slow release pellet. So we've already done 2 of the 4 treatments, and we'll do another one coming up in 2015, and another one in 2016. I'll show you what that's going to look like. One of the things I want to show you is this was a multi-agency effort. I mean, this is a lot of money. I mean, this is just $600,000 plus for the product, not counting everything else, the labor, the boats, and the equipment and all that kind of stuff. And we got lots. We chased this. We went hard at it. And the big player for us was Kenai Peninsula Borough. They ended up 400 plus 40, so $440,000. And that's because we convinced the borough mayor, Mike Navarre, that this really was bad. It was going to threaten salmon on the Kenai Peninsula. He got it. He understood it. He took it to the state legislature, and he got a special capital appropriation. Here's the chemical. Here's the products we use, or the equipment we use. This is the blower for the pellets. This is the hopper. It just shoots it out. It's a gas-fired pellet spreader. This is the pump that we use for the liquid form of fluoridone and NSM for the dicot. And what there is this is the mixing tank, and this is the pump that's drawing it out of the mixing tank so that you're mixing water with the chemical. And then there's also a transfer pump where we're actually pulling lake water into this holding tank, the mixing tank. One of the things we did is during the actual treatment, we put these floating booms in place, and there's about two or 3 feet of netting down there. So fish can still swim underneath, salmon, coming upstream. But most of your fragments are floating at the surface, and we were trying to intercept them from going out the outlets of the lakes. And somebody mentioned the fact that you've got to treat everything at once, and you're absolutely right. So we've got to stop this even as we're running boats back and forth, putting this stuff down. There's Andrew over there, looking like Captain America. And so this is when we're deploying. We're backing up here, and we're starting to get ready to deploy. And we're doing this by the number. Everybody is a DEC certified applicator. We've got spill kits sitting there. We've got everything. I mean, we're doing this. We're federal government, and if we screwed up, the litigation would be horrible. Here's the liquid applicator. So the pump is mounted right here. The holding tank's here, and you've got hoses. One hose here, and another one on the other side of the stern, and they're just dribbling it in the back of the boat as you run down your transects and you're applying this. That's the liquid form. Here's the pelleted form. There's a guy. Here's the hopper in the back. And this hose here, this is the pellets. And all the guy's doing is he's going back and forth like this as you're running a transect. And he's spraying this out at some specific rate. All these are rated. And the way we know where we're going is it's just standard stuff. We're taking our GPS, and we've got these transects pre-marked, so we know exactly where we're going, and we follow them. And we follow them at some set speed here. Protocol calls for 5 miles per hour, and we're following it, and we're going back and forth, so we know what we've covered and where we're going. The question is, does it work? So this is the fluoridone over here on the left. This is parts per billion, and keep in mind that the maximum amount you can apply is 150 parts per billion. Well, we're not even close to that. Our target is about 8 parts per billion. That's what we want to run it at. So if you look over here, Beck Lake, and the triangles here are the application dates. And this first one is in June 3 and 4, and that was Beck and Daniels. Stormy, we didn't get to July 23rd. And the reason we did is that was after the state fiscal year. We didn't get the funds from the borough that was getting it from the state till, they didn't get their money till July 1. So we weren't able to actually get out there till July. And then all three lakes were treated in mid-September. And so these are the fluoridome samples. Again, Back Lake's the whole lake treatment, and we're running right around 8. And it's right where it should be. This last sample, this is in weeks. This last one was just taken last week. Again, we went out, drilled through the ice, got water samples. And so we're still running it at 8 parts per billion. You look at Daniels is that partial lake treatment. And it's never running quite as high as we'd like it to be. It's running about 4, but again, here in February of this year, this past month, we're right out here. Stormy's running a little bit high. It's running around 10 parts per billion. And one of the reasons why it was running so high is that when we applied it in mid-July, there was already a heavy thermocline set up. We know this because we had temperature probes out. And there was a heavy thermocline so that the lake water wasn't mixing. So again, is it working? This is what Elodea looks like 2 weeks after application. Keep in mind the target window is kind of like 45 days to 60 days after. So this is 2 weeks after, and you're starting to get a little bit of pink going on here. 8 weeks into it, or 32 days, it's starting to get pretty brittle. It's looking pretty much like crap. And then by 14 weeks, the stuff is horrible. I mean, you can't even find green pieces. So I don't know how well you can see this, but what we did was we set up 50 points on each of the 3 lakes, and they were pretty systematic, except that when we actually got to the site, we actually carved the lake perimeter up into 50 segments, equal segments, and then within each segment, we subjectively picked a point because we really wanted to find points that had Elodea, because the whole point was to figure out whether or not this is working. So this data, the percent occurrence here is based on 50 points in each of these 3 lakes. So these are all done in May of 2014, so before we did the treatment, right after ice out, okay? And basically, in Beck, Daniels, and Stormy, you can kind of see the distribution. Beck Lake, we think, is ground zero. That's where we think it was first introduced onto the Kenai Peninsula. And then we even have a storyline that goes with it. We think it was done in the 90s when there was an aquarium shop in the local area. But anyway, so 70% of our 50 plots have Elodea, 22% in Daniels, which is the partial lake treatment, and then 50% in Stormy. This is the relative abundance, and this is on a scale from basically from 0 to 3. So 3 being a lot, and 0 being none. And so you've got this average value of about 1.5, and about 3/4. This is what it looks like in September after our 2 treatments. In Beck Lake, we dropped from 70% to 12%. Our average abundance goes from 1.5 to we're really trending down there. We had a hard time finding Elodea in Beck Lake. Daniels, it went from 22% to 0, and it went from 1.5 to 0. And again, this is a little bit deceptive because if you recall Daniels Lake, the partial lake treatment, that's the lake that we put in the contact killer. So we got an immediate response. It's a little bit deceptive, but truthfully, the difference is what's happening now. We have this water that's laced with fluoridone, so that as that plant tries to grow back, it's basically growing back into a lake water that's got fluoridone in it, and it's not going to survive. I'm feeling pretty confident that we've nailed this lake. Stormy Lake is different though. Stormy Lake, again, we didn't get out to do the first treatment until July, mid-July, or actually the 3rd week until July. And so the lake had continued to grow during that period. And so we had a fairly negligible impact on Stormy. So we went out to survey in September. There was still, it looked like Yap Lake, there was still a lot of Elodea floating around. But the thing that gives me hope was we were just out there in February. Here's the difference. I told you in February of 2013 when we punched the auger through Stormy Lake and we popped it out. The very first hole, Elodea just spewed out all over. It was inside floating on the surface. When we went back in February of this year, we couldn't find it. You couldn't see it floating in there. It didn't pop out on ice. It's gone. And I'm actually thinking when we go back in the spring, we're going to be in very, very good shape. In other words, I think it's having herbicidal action all winter long. The only comment, obviously you can't read this, but the only comment I want to make is that we kind of jumped on this. We found it, we first detected it in September of 2012. We figured out a game plan, we wrote the prescriptions, we did all the permitting, we raised the money, we got the equipment, and a year and a half later, we were applying. That is record fast government work. And here's my message to you guys, and this is why we can't wait, and this is real stuff, okay? So early on, and of course, it kind of carries over a little bit strangely here, because you guys have had it idling down here since 1982. But elsewhere on the Kenai and in the Matsu and Anchorage and in Fairbanks, I mean, in all cases, we're fairly convinced it was an aquarium dump that got it started. And as an aquarium dump, that's how it first gets to some of these lakes. But that's not the issue. Once it gets infested and gets cranked up, in the then boats start moving around. This is a fictitious photo. This, we doctored this up. I hung Elodea on the prop. This is a real photo, and this is a Forest Service contracted plane flying out of here, our Cordova, with Elodea on the back. That's for real. This is very similar to something that was shown you earlier, but Alexander Lake, we know that Elodea came from Sand Lake, and that's because it's right in front of the cabin from a guy who has a floatplane who lives on Sand Lake. He's pretty much acknowledged that he probably brought it up and he said go get rid of it. So from Alexander Lake to Anchorage is a 50-mile as the crow flies. So these are circles are 50-mile radiuses. Why? Because we know that you can carry this for 50 miles. We know that. I mean, it's been demonstrated. You put that 50-mile circle around Anchorage, and you put that 50-mile circle around Alexander Lake, and around McKiskey, and around Cordova, and around Fairbanks. I mean, we're talking some serious spread. And all it has to do is jump to another lake, and then you draw another 50-mile circle. I mean, this is bad stuff, and it spreads really quickly. And that's really why, I'm so hopped up on you guys doing something here in Cordova. I think we're pretty much done here. I don't want to go through all of this, but at the end of the day, the fact that it costs a lot of money, I mean, I'm telling you guys, don't worry about it from the short run. The main thing is you guys, get together, you write your integrated pest management plan, and I think money will come. It's going to take hard work. Somebody's got to chase it, Danielle, wherever you are. Somebody's got to chase it. And I think that's it. Any questions? Yep.
So you talked about money, and I was just looking at your lakes.
How much yours is going to cost?
And we've got 9 lakes or something like that.
I'm guessing 5 to 6.5 million for you guys. But on the other hand, what I'm saying is take a look at what some of Lars figures for,
Oh, I know. I'm not disputing that. It's just I was just going, how are we ever going to get that kind of allocation?
Well, that's why. It's a lot of money. But I think it's worth chasing. I think there's a slim chance you guys can still pull it off. And I mean, it's one of these things that you can't blink. You gotta find people to help. You gotta find the state. You gotta find the Forest Service. Yes, sir.
Which agency is best suited to take the lead on?
Well, DNR is it. But when you say take the lead, that's a tough one. There's always individuals that make a difference. In any given kind of interagency effort. On the Kenai, I can almost guarantee if I hadn't been involved, it wouldn't have happened this fast. Okay? And I'm Fish and Wildlife Service, but that has nothing to do with it. I mean, I'm working with DNR, I'm working with, all the different agencies. So you just need one individual who kind of like the fire and go. Somebody's got to do it. And that's what happens. And of course, it's critical to work with the right agencies. And here it's very obvious we're talking Forest Service, the Watershed Project, and DNR. I mean, those are the 3 big entities. And anything you get beyond that is great. Yep.
And our last speaker tonight is Gordy Reeves, and he's from the U.S. Forest Service, and he's going to talk a bit about some research planned in Yak Lake for this summer.
Okay. So actually, we're just really formulating the idea for what we want to look at the ecological role of Elodea. It's been here for a while. There's some interesting assumptions have been made about that it's negative on fish and fish habitat, and I don't think that's proven yet. It may be down south, but I don't think it's something that we should automatically assume is a reason that it should be eradicated here. There may be other reasons. But we want to look for the ecological role of Elodea in these systems. So it's going to be the Forest Service, myself from PNW. We've been working for the last 10 years on looking at climate change impacts on the Delta with folks from Marty Berg from Loyola University of Chicago and Gary Lamberti at Notre Dame. And so we're going to put together a project this summer to quickly look at the potential roles of Elodea. And we've seen, I don't need to go through this, certainly this area is a hot spot for Elodea invasion. And we've seen how it behaves, these dense maps. But the question is, what's going on ecologically with these things, okay? So we've identified, we're going to look at 3 lakes, Eac, McKinley, and Martin. We're going to look at ponds and sloughs down Ibex, Eac, out along Allegheny. And this circle here, the orange circle on the far right, it turns out that fortuitously, we studied that area before it had Elodea. We've got a really good record of what was in that pond and the ecology of that pond prior to Elodea getting into it from some previous work. So we'll have a really good sort of before-after comparison. I think one of the few places that we'll have that. So what we want to do is look at the role of Elodea, okay? And it's interesting. Again, we've made some assumptions about it, but what we've seen is it potentially could be providing ecological benefits in these lakes. It could be a place that's a refugia in terms of from predation, and we've seen this. We've seen juvenile coho found in these beds. It probably is a real important role for cover from predators. If you go to Martin or you go to McKinley and look when the fish are first coming in, there's oftentimes a lot of seals in the lake. Look at where the fish are concentrated. They tend to be around these Elodea beds. And so are these Elodea beds again serving as a predator refuge in these systems? The other thing is there's some interesting things going on with non-salmonids, believe it or not, with Elodea beds. We've been working with Brian Nielsen, who was a former employee here. We looked at whitefish in McKinley and Martin Lake. And where we saw the biggest concentrations of whitefish were in Elodea beds. And we think what it was is one of the things that may be going on, it looks like there's a particular invertebrate assemblages associated with these beds. And in the case of McKinley Lake, Elodea beds had these high snail populations, and that was a major food source for these whitefish. The other thing is we look at, like out at Martin River in the springtime, you wouldn't believe the number of suckers that are out there. The great northern large-scale sucker, which is the only sucker that's native to Alaska. But there are large numbers of these suckers in these Elodea beds. And we don't really understand why. But one of the things may be this may be an important spawning habitat for these areas. The broadcast spawners, and this may be a potential area that is actually contributing to the ecological success of these species. So what we're going to do, we're going to look at a range of species, coho, sockeye, jolly barton, cutthroat, the whitefish, and the suckers. We want to do monthly samples in the lakes, looking at how these beds are used over the course of the day, not just at one single time, but look at over a 24-hour period. Use snorkels, probably do some snorkeling and scuba gear, and then sample these beds and compare what goes on in these beds compared to maybe some areas that are Elodea-free or with some of the native vegetation. We're going to look at the invertebrate assemblages associated with the Elodea and the non-Elodea areas. And we're going to look at both aquatic insects and then look at zooplankton, potential zooplankton uses of these and concentrations in these areas. Because again, I think we can talk about eradication, but we might want to think if there's an ecological role that Elodea is playing in these systems, we need to think that there may be implications of complete eradication, how we go about eradication. And we have to do it more slowly so that the native plants can reestablish those areas. Or Has Elodea really just stepped into a vacant niche in these lakes? Is it something that, have they